For October planted cereals, we would say one application of insecticide is sufficient to protect yield. If you're planted in November and it's emerging later, generally you wouldn't need an insecticide, because the idea is that as we move into the winter, it's meant to get colder. When it gets colder, aphids are less active, they're flying less, so there's less of a risk of them getting into your crop. But if you were in a high risk area, maybe beside the coast, or it was a very warm winter, the risk may be higher. But generally, where they're emerging in November, they don't need an insecticide.
BYDV, or Barley Yellow Dwarf Virus, was a serious issue in many crops last year. The favourable weather this autumn has allowed early planting, but this also means these crops are at higher risk of BYDV. While many of our winter barley varieties are now rated as BYDV tolerant, does this mean we should manage them any differently to other varieties? You're listening to the latest episode of the Tillage Edge with me, Michael Hennessy. We'd really appreciate it if you could listen, follow, and give us a review on Apple or Spotify, or wherever you get your podcast from. Crops have emerged quickly, and many fields are now starting to show a green hue as they enter the vulnerable stage for BYDV. Today I'm delighted to be joined by Dr. Louise McNamara, an entomologist from Teagasc, to discuss the best strategies for controlling BYDV this year. Louise, you might just tell us first about how BYDV affects different cereal crops, and also, is there a variation in the level of risk depending on the area of the country you're in?
So BYDV can, first of all, it can affect all cereal crops, and it can cause significant yield losses in any cereal when you have sufficient virus pressure, and it can affect both the yield and also the grain quality. What determines risk for where you are and whether you're going to have a lot of BYDV or not is very complicated, and it's dependent on a lot of different factors, which can make predicting BYDV pressure very difficult. So, for example, some of those factors could be the sowing date, how close you are to the sea, because you might get less frost, the presence of semi-natural habitats, permanent grassland nearby, field size, weather, temperature. So there's a lot of different factors at play that determine whether a field will get high levels of BYDV or not.
Okay, so I will probably touch upon quite a few of those as we go through over the next little while. But just going back to last year, and I think a lot of farmers might have it in their mind, it was quite a bit of BYDV and lots of different winter crops, I suppose, especially. But also maybe people might have had in their mind, God, it was an awful wet year. Surely to God that would have stopped aphid movement, drowned the feckers, or did something at least anyway to try and stop it. But there still was a lot of BYDV. Why is that, or why was that?
The levels of rainfall can reduce aphid flight, but there's two different ways your crop gets infected. One is primary infection with new aphids coming in, and then that will be affected by rainfall. So the aphids are less likely to fly when it's colder and there's heavy rain or heavy wind. But there's not enough research done on what is happening or with aphids already in the field. So if there's aphids already in your field, or maybe they're walking in from the hedgerow or arable margin, we don't know how rain affects those. So that may not be able to knock back them or prevent them from moving around, reproducing and feeding.
And in terms of those aphids arriving into the crop, how long, generally speaking, does it take for the aphid to transmit that BYDV? And is it, I suppose, on the other side of that, is it the first infection you talked about a second ago, or the first movements of aphids, or is it a bit more longer term?
So how quickly it takes for them to transmit the virus will depend on temperature. So temperature will affect how active the aphids are, but it will also affect the virus itself. And also it's whether they're already carrying the virus. So if they're already carrying the virus when they land in the field, they can start transmitting the virus straight away when they start feeding on a plant. If they don't already have the virus, they have to pick it up. And then from the time between picking it up, which is called acquisition, and being able to pass it on to the next plant can be anywhere from a couple of hours to 48 hours. And then, when they produce offspring, the offspring is born without the virus, so they have to pick it up themselves again through feeding. So there's a delay for when they first pick up the virus of a number of hours to a number of days from where they can then spread the virus.
Okay, and that's where we get the rings. Is it where the is that the primary or the secondary infection where we get?
So the rings is you see those rings of yellowing in your crop. That's generally where an aphid lands in. Maybe so you could call that primary infection, the first infection, and then it radiates out. So that means it's feeding around the plant and then reproducing on the plant. And when the plant gets over full or starts to run out of nutrients, the aphids will start making wings and start moving around. So what you see that ring is it's spreading out from the first point of infection out.
Okay. And at that point then, Louise, is there not, a degree of natural predators or if you like beneficial insects out there that are trying to help to control those aphids to give some level of control, or is there but just not good enough or quick enough?
So aphids do have natural enemies, so things like spiders and beetles and parasitoid wasps and ladybirds. But there's lots of studies on how natural enemies reduce populations and number of insects, but there's less studies on how they affect virus incidence in the crop because it may not take very many aphids surviving to spread the virus. We don't know exactly how many aphids you need to have significant virus pressure. And then when we think about the different types of predators, there's generalist predators and specialist predators. So the generalist predators may already be in the field because they live off other things to keep them alive, so other food sources. So they're able to start feeding on the aphids early, maybe before they have big bursts in populations. But when you think about something like a specialist predator, like a parasitoid wasp, they probably won't be as much help because they only appear when you have large numbers of your pests. And at that stage, you probably already have a good bit of virus. So the challenge with natural enemies is yes, they play an important role in keeping levels of pests down, but whether they can keep the level of the pest at below a level that will prevent BYDV spread is another question because we don't know how many aphids you would need to have below to reduce your virus pressure.
Certainly not reliable control, at least, anyways, I
No,
suppose,
no.
is what I'm picking up from you. On the other side of it, there's lots of different ways that people are establishing crops, and certainly in this year, seeing as it was really nice. There's ploughing, but there's obviously min-till or the non-plough type scenario. Would the stubble or the straw that might be left on top, does that help to deter aphids coming into the field in the first place?
So it can affect aphids because aphids use visual cues to help them find plants and to land. So it could help reduce your primary infection because if the aphids see the contrast between the plant and the soil, it's harder for them to find a plant and to land. And that could be the case in minimum tillage or in things like straw on the ground and stuff like that. It can disrupt the visual cues that would help them land and maybe reduce primary infection. Previous studies in Teagasc by Tom Kennedy showed that minimum tillage had less BYDV, lower symptoms of BYDV than conventional tillage in 2 out of the 6 seasons that was tested. So it can help, but again, whether it's a reliable control you can guarantee is a different thing.
We're talking a good bit about and we probably haven't mentioned the various different aphids, but I'm sure you will in a second. But just in terms of, lots of farmers out there, they've planted crops, it's relatively mild. Should a farmer be going out to have a look to see whether there's aphids in the field? And I suppose maybe even the second part of that, is that even helpful in terms of there's lots of different aphids out there. Some are harmful or potentially harmful, and others maybe not so much.
So monitoring of pest levels is considered a very important IPM tool, and it works very well where you have thresholds. So for example, when you're thinking about aphids on the ear later in the season or some of the pests in oilseed rape, there's a threshold where if you reach a certain number, you do or don't need to act. So that's where monitoring is really, really useful. So monitoring is still advised in cereal crops for aphids for BYDV. But the challenge is they're hard to find. They're very small. There's a lot of different species. When you look at an aphid, you don't know if it's carrying a virus or not. So it's only the ones carrying the virus that we're most concerned about. And there's no threshold then. So if a grower finds 2 aphids or 20 aphids, we don't know what the difference really means. So we have a project at the moment where we're looking at different types of monitoring methods. So visual searching, which is what's currently recommended, yellow trapping and using suction towers and seeing which of those is best to reflect what's happening in the field. So we do have ongoing work at that at the moment so that when you're putting effort into searching for aphids, that you know what the numbers would actually mean and what's the best approach to search for them.
Okay, so with all the very different elements within that, a lot of crops are at kind of 1 to 2 leaf stage at the moment. Probably the early kind of sown crops certainly are any of the ones who are maybe sown around maybe the 20th of September or thereabouts. So what's the strategies that people should be using on those earlier crops? And we'll talk about that maybe later sown crops in a minute.
So the strategy for the early sown crops, so those sown in September, which a good few crops will be this year, is that they would be considered medium to high risk, obviously depending on where you are and other factors. But the advice would be that they should benefit from a spray at the 2 to 3 leaf stage and then a second spray in early November.
It's as straightforward as that, rather than looking or anything like that. That's a straightforward advice.
That's the
Across the
advice
board
at the
nearly.
moment, yeah. That's the
Okay.
advice at the moment, is that they would be medium to high risk, so they may benefit from 2 sprays. Now, if you don't get out, say you've got your 2 to 3 leaf spray out, but then maybe the weather changes and you don't get out for your early November spray, the research has shown that there could be a benefit to spraying up to January or February, depending on if virus pressure is still there, which you don't need more than 2 sprays, and there's no benefit in spraying after growth stage 31. I mean, the crop can still go yellow if it gets infection after growth stage 31, but it will have no major impact in yield.
And quite a few growers have, and maybe as they've had a number of other years, they've planted BYDV tolerant varieties. Should they be treated any better, or I suppose why are people paying more money for it? I suppose.
So tolerant varieties are an important tool, and they're going to be a very important tool into the future. But for now, early trial results do suggest that they're promising, but we don't have enough evidence yet to say whether they're sufficient on their own without a spray in high pressure years. So for now, we would say treat them the same and apply an insecticide if it's recommended based on your planting date. So that they are an important tool, but for now, we don't have enough to say that they're enough on their own.
Okay, and we're talking about putting an insecticide out to control some of these aphids. We know there's some resistance in Ireland.
Yeah.
What's the current status of that? Is it going up? Is it going down? Or whereabouts is it?
So Maximilian Schuchart, a PhD student in our team, has recently finished his PhD looking at resistance in grain aphids, and he was looking at the levels of resistance post the neonicotinoid ban. So neonicotinoids were banned in 2019, and we wanted to see, now that we just have pyrethroids, would the levels of resistance gone up? So he monitored over 150 fields over 3 years from 2021 to 2023, and he found that resistance has not increased since the ban. And then he also looked at the ability of resistant aphids versus susceptible aphids to transmit BYDV, and he saw that resistant aphids were not more efficient vectors of BYDV, so that's good news.
Okay. Why do you think that the levels of the resistance isn't increasing? Because generally, weeds and lots of other things, once you get resistance, it just tends to explode and kind of that's the end of it. But why is this different?
Well, it could be that when you think of aphid, so the grain aphid, the aphid that has resistance, its main hosts are grasses and cereals. So if the cereals aren't there, they're probably in grass, and we have quite a lot of grassland in Ireland. So the area which grain aphids are covering is much bigger than the area which is being sprayed. So it's probably that there hasn't been enough pressure on the population to change the overall breakdown of the population across the country.
And obviously in grassland isn't getting any insecticides at any stage ever, I suppose. So there's no great pressure.
And grassland is a very important reservoir of grain aphids. They will often be in grassland when they're not in cereals.
Okay. And just in terms of the resistant ones that are there present in the population, is there any penalty for that aphid to be resistant in the first place? Are they more easily killed by frost or predators, or is there anything that's kind of keeping them in check as well on the other side of it?
So we know from studies we've done that they're more susceptible to being parasitized. So when aphids are attacked by parasitic wasps, so they're wasps that lay their eggs in aphids, that they release an alarm pheromone to warn other aphids to run away. But resistant aphids, they still release the alarm pheromone, but they don't respond to it as well. So they're more likely then to get killed by parasitoids. So that's obviously positive for us. There could be other fitness costs, so maybe they respond differently to climate or temperature. So that's something we will look at as well in our lab.
Just before the last question, I just want to just go back to, so for growers who are planting, say, over the next week or 10 days, what sort of BYDV prevention should they be looking at?
So for October planted cereals, we would say 1 application of insecticide is sufficient to protect yield.
And if you slip into November, is
Yeah,
it
so
still
if you can't,
more?
or well, if you're planted in November and it's emerging later, generally, you wouldn't need an insecticide because the idea is that as we move into the winter, it's meant to get colder. When it gets colder, aphids are less active, they're flying less, so there's less of a risk of them getting into your crop. But if you were in a high risk area, maybe beside the coast, or it was a very warm winter, the risk may be higher. But generally, where they're emerging in November, they don't need an insecticide.
Okay. So, Louise, just to circle back a little bit to the research that you're doing, and you have a huge program of research in this area in general. You're trying to, I suppose, bring the industry to a more precise timing as regards that whether it's a spray or no spray, or where you should spray, that kind of thing. You might maybe just give us a little bit of an insight into where you hope we might be maybe in the next 3 or 4 years.
Yeah, so what we're hoping for the future is that we would be able to use decision support tools and use them in combination with things like your tolerant or resistant varieties. So what decision support tool would be able to do is predict the level of risk in a field. So at the moment, other than looking at weather and planting date, we can't say for any particular field what's the risk of that field getting BYDV. So at the moment, we're trialing a decision support tool developed by Teagasc called Acrobat to see if it could be used in Ireland. So it combines different models that are out there for aphids and BYDV, and it looks at things in your field like sowing date, your weather, your aphid numbers, the percentage of aphids with virus, and it makes a prediction on the level of risk of getting BYDV for your crop. So we're testing if that would work in Ireland. So it's actually developed in the UK for their main vector, which is the bird cherry oat aphid or paddy, while our main vector is the grain aphid. But we want to see if the model can be transferred to work here. And we're testing that on both a plot and a tramline scale. We're on our 3rd year this year of testing it. So hopefully that's what we would like to see in the future, is that there's more information to help farmers make a more precise decision. So it's not so much about knowing exactly when to spray, because we can estimate roughly when to spray and when to get a good benefit from spray. It's to work out the years you don't need to spray. And that's what we really want decision support tools for.
Okay. And do you think that in the next year or two we'll be closer to the results of that?
Yeah, so probably, in the next year or two, we would have the results from Ireland on a plot and tramline scale, but we'll have to see whether that model would work for Ireland, because, as I say, it's built on a different main vector. What we also have is a new project starting called AgriAdapt, a DAFN funded project that looks at developing new models for Ireland. But obviously that will be further down the line, because you'll be starting from scratch with that.
Louise, as always, thanks very much for your time. I think there's loads of information there, and we'll chat to you again soon.
Thank you.
So that's it for this week, and my thanks to Louise for joining me on the show. If you enjoyed the podcast, then recommend it to a friend or colleague, and as always, rate and follow on Apple or Spotify so you never miss an episode. And for more information, go to teagasc.ie. I'm Michael Hennessy, thanks for listening, and I'll be back next week with more tillage news and advice.